Welcome to VGuide TV. In this video, I'll explain motion. This is motion part 2 video. First, I'll discuss an equation for displacement of the body in the nth second. We know there are three equations of motion is there. That is V equals U plus AT, S equals UT plus half AT square, and V square minus U square equals 2AS. We know these three equations. But now I am discussing another equation in which displacement of the body in nth second. What is the difference between n seconds and nth second? N seconds, nth second. These are different. Say for example, if I am telling 6 second and 6th second, they are different. 6 second means I am taking the time from 0 to 6. 1 second, 2 second, 3 second, like that 6 second we are taking. But 6th second means it is between 5 second and 6 seconds. What happens in the middle, or it is that duration between 5 second and 6 second. So I'll give you an equation to find the displacement of the body in a particular second, that is nth second. So I told you here an example, 6 second and 6th second. 6 second I told it is from the time interval 0 to 6 second. But 6th second means it is in between the interval of 5 second and 6 seconds. So I am using my second equation, S equals UT plus half AT square. Here I am taking the displacement in an n second, say for example 6 second. So I am calculating what is the displacement in 6 seconds. So it is S6 is equal to UT. In place of T I am using T as, in the first case I am substituting T as N. So U into N plus half A N square. This equation in place of T I substituted N. That's all. Now when I asked 6th second, I told it is between 5 and 6 seconds. So if I am taking the time as T equal to N, next time you have to take T equals N minus 1. T equals N minus 1. So what you should do is you have to substitute the value of T as N minus 1 in the second case. So Sn minus 1 is U N minus 1 plus half A into N minus 1 the whole square. Same thing. We are substituting this equation in place of T as N minus 1. Now, I told you it is in between these two intervals. So, the displacement of the body in nth second is Sn minus Sn minus 1. That is displacement in 6 seconds minus displacement in 5 seconds. So, I am substituting the equation. Sn is right side un plus half a n square minus Sn minus 1 u n minus 1 plus half a into, I expanded this, a plus a minus b the whole square. A square minus 2ab plus b square, n square minus 2n plus 1. Open the bracket, un plus half a n square minus un plus u. This minus I am multiplying inside and I got half a n square plus a n minus a by 2. Un minus un cancel. Half a n square minus half a n square cancel. The rest term is dn equals u plus a by 2 into 2n minus 1. So you can add this equation also as a fourth equation, dn equals u plus a by 2 into 2n minus 1. This is my fourth equation. First equation, second equation, third, and this is our fourth equation, that displacement of the body in nth second for a body going under uniform acceleration. See a question. Why I told this equation? To solve the next question. A body from rest describes S1. A body falling from rest describes distances S1, S2 and S3 in the first, second and third seconds. of its falls. First, second and the third seconds of its fall. Then what is the ratio of S1 is to S2 is to S3? In the question they told first, second, third second. So they are given for the first second, second second, third second. So you should understand that you have to use the equation. Which equation only? U plus A by 2 into 2n minus 1. Now the bodies start from rest. So U will be 0. It is falling. It is under its freely falling case. Body falling from the rest and it is coming down. So we are taking A as G. So I am substituting here Sn equals U plus A by 2 into 2n minus 1. Sn or Dn, no problem. So first I am substituting n as 1. U is 0 plus A will be G by 2 into 1 minus 1. So it is G by 2. Substitute n as 2. S2 equals 0 plus G by 2 into 2 minus 1. That is 3G by 2. Third one, substitute n as 3. 0 plus G by 2 into 3 minus 1. So it is 5G by 2. So if you need the ratio of S1 is to S2 is to S3 equals G by 2 is to 3G by 2 is to 5G by 2. All the G by 2 get cancelled. So we get an answer 1 is to 3 is to 5. So you see, if you know the equation, you can do the questions very quickly. So S1 is to S2 is to S3 is 1 is to 3 is to 5. Like that it goes, right? Or if the last term, nth term, if they are asking, you can write it goes up to 2n minus 1. If they are asking for more, S1 is to S2 is to etc. If they are asking 1 is to 3 is to 5 is to etc. Till what time it will come? 2n minus 1. Like that also they can change the question. Clear? Now, a body start from rest at time t equals 0. The acceleration time graph they are given. What is the maximum velocity? See here, they gave y-axis as acceleration and x-axis as time. Y-axis they gave 10, x-axis they gave 11 second. And remember, it is an acceleration time graph. Remember this important point. Area under acceleration time graph gives change in velocity. How we can tell that? Take the equation V is equal to U plus AT. Okay, so what is AT? AT is nothing but V minus U. So if you take the area of this part, it will be equal to V minus U. So it will be equal to change in velocity. So if you want, well, maximum velocity they ask. So we can take here the initial time, the acceleration they are given 10, then later it's coming as 0, right? So I can take here this case, I can take the area half into base into height. Half into base is 11, height is 10. Half into 11 into 10, that is 55 meter per second. That will be the maximum velocity. That will be the maximum velocity, because they gave it in the question, the body start from rest. So U as 0. If U as 0, we can write here AT is nothing but V, and this V is the maximum velocity here. Clear? So remember, the area under AT, it means acceleration time graph gives change in velocity. And I gave you another one. What about the area under velocity time graph? The area under velocity time graph gives displacement. Area under velocity time graph gives displacement. Clear? We'll go for the next question. It's a very, very important sum. A small ball is dropped from a balloon moving vertically up at a speed of 10 meters per second. When the balloon is at a height of 15 meters from ground, neglect the air friction, take G as 10 meters per second square. Which of the following is not suitable for the present situation? Ball reaches the ground in 3 seconds. Ball covers the distance of 25 meter. Magnitude of average velocity is 8.33 meter per second. Ball moves at a speed of 10 meter per second at an instant when it is dropped from the balloon. So they gave many cases. So the question is, we have a balloon here. Okay, we have a balloon. This balloon is, I just marked it here. I have did question answer here. So you see the case here, we have a balloon. So this is a balloon. Okay, this balloon is going. Okay, so when the balloon reaches a height of 15 meter. So say for example, here you check it. I'm just checking here like this. So I'm telling here, this is the ground. Okay, so the balloon, when it travels a distance of how much? 15 meter. From here, a ball is dropped down. Okay, still the balloon is going up with a velocity, right? So we need to find first what is the time taken, because in the option they told the ball reaches the ground in 3 seconds. Like that also question they can ask. So you remember in the case, at time t equal to 0, the ball was going up with a velocity of 10 meter per second. After that, it moves as a freely falling particle with a downward acceleration. So what I am taking first is, in first case, your ball is inside the balloon. So while going up, while balloon is going up, we can tell that the balloon is going up, your ball is inside the balloon. So ball also has that velocity. So here I want to tell a very important thing. Here u is velocity, initial velocity going up, but the gravity is down. So u and g are oppositely directed. In those situations, if you need the time equation, or if you need the time, you can use the equation s equals ut plus half gt square. But remember, u equals minus 10 because it is against gravity. Okay, displacement they are given. What is the displacement at this point? 15 meter. G as 10. So I can write here A is nothing but in this case it's G. So I can write 15 equals minus 10t plus half gt square. 15 equals minus 10t plus 10 by 2 is 5t square. 5t square minus 10t minus 15 equal to 0. Taking 15 to the other side. Divide with 5. So it is t square minus 2t minus 3 equals 0. This is a quadratic equation. If we solve the quadratic equation, t minus 3 and t plus 1 are the terms, right? We can factorize it, that t minus 3 into t plus 1. So from this, I can write t minus 3 equal to 0. Therefore, t is equal to 3 seconds. I cannot take t plus 1 equal to 0 because in that case time is coming as negative. So you can take the case in which the time taken for the ball to come down is 3 seconds. So remember what I told, a balloon is going up, a ball is inside the balloon. When the balloon reaches a height of 15 meter, a ball is dropped from that. But remember, we need to find the time taken for the ball to come down. So at this point, the displacement is 15 meter, but the velocity and gravity are oppositely directed. So that's what you take u as minus 10. Substitute, you can find the value of t. You get a quadratic equation. We are solving quadratic equation. Clear? Now, second thing, see the option they are given about ball covers a distance of 25 meter. I need to check it, how much distance your ball is covering. Okay. So for that, what we are doing, now the balloon is already reached a height of 15. At this point only the ball is projected or the ball is dropped. But at that point, again your ball has the velocity of the balloon. Okay. At that point, your balloon, your ball has a velocity in which the same balloon has, right? So it goes to little more height. Okay, because it is from a body, moving body, the body which is moving up. So it goes little up. So what I am taking, this point u as 10, it goes up to a height. Then after that it's coming down. Okay. Then after that it's coming down means when it reach a maximum height, their final velocity becomes 0. So that is the reason I wrote v equals 0, u equals 10, v square minus u square equal to as. So here I can take as, if you take here u as minus, no problem. This is minus, if you are taking this minus will get cancelled because it's square. Then it is equal to 2 into 10 into s. So s I can take it as, what is the value of s equals 100 by, you can take here the 100 by 20. 100 by 20 is nothing but 5 meter. So what I want to tell, when we drop a ball, the ball moves little up. How much it's moving? 5 meter going up. Same like that 5 meter will come down. Then it is coming back. Right. So they are asking here for the balloon. What is the for the which one? For the ball. Ball covers how much distance? Ball covers distance means what we have to take here. From here the ball is coming out. So it is traveling up 5 meter, again coming down 5 meter, and this distance, what is this distance? 15 meter. So it's covering a distance of 15 plus 5 plus 5, that is 25 meter. Clear? 15 plus 5 plus 5 is 25 meter. So we are calculating distance only. So no need of taking sign. Okay, no need to bother about the sign. So we can take it as 25 meter is the distance. So that option also correct. If you take average velocity, you see I told 5 meter going up, 5 meter coming down. So its displacement is 0. So its displacement is only this distance. So this distance means nothing but 15 meter. So what is 15 divided by what is the time taken? 3. 15 by 3 is 5 meter per second. So out of this option, ball reaches ground in 3 seconds is correct. Ball covers a distance of 25 meter, that also correct. But the average velocity of ball is not 8.33. I got it at 5 meter per second. That is wrong. Ball moves up at a speed of 10 meter per second at an instant when it is dropped from the balloon. That is correct because I have taken here. When the ball is dropped at this point, the ball travels with a speed of, what is the speed? 10 meter per second. Okay, you can do that in another form. If you're taking this u as plus, you can take g as negative. In that case also we get the same thing only. Clear what I told? So in this case, what we are doing is, a balloon is going up. When the balloon is going up, balloon reaches a height of 15 meter. What happened when the balloon reaches a height of 15 meter? A ball is dropped from the balloon. So what we are taking, first I am calculating when the ball is dropped means what is the time taken for the ball to come down. This type of question, no need to think anything. When instead of ball from a rocket or from a helicopter, we are dropping a food packet. Those all type of question we use this equation. S equal ut plus half gt square. So displacement is 15, u because the velocity is going up but gravity down, so minus. So when you substitute 15 minus 15 equals minus 10t plus 5t square. When you substitute, I get a quadratic equation. If you solve the quadratic equation, we get the value of t as 3 seconds. Okay. Why we are not taking t plus 1? Because if you take that, the time is coming as negative. Time cannot be negative. Time cannot be negative. Some people will get the, they may get the doubt like why I did not take the second term. Because time will come as negative. So the first I calculated what is the time taken. Time taken for the ball to come down. Second thing, I am calculating what is the distance covered by the ball. So from here I am starting. Just now we told at this point the ball is getting the velocity of 10 meter per second. It goes up, it goes to a certain maximum height. At that point final velocity becomes 0. So in that way, v square minus u square equal to as, you can substitute and you will get value of s. How high, how far or how much height more it travel. I got it 5 meter. So distance when we are calculating, it goes 5 meter, again it is coming back 5 meter, and this 15 meter. So what is the total distance? 15 plus 5 is 25 meter is the total distance, not displacement. But in the third option, they are talking about average velocity. What is average velocity? Net displacement by time. What is the net displacement? When the ball is going up, coming down here. So up 5 meter, down 5 meter. 5 meter cancel, because this is going up, this will coming down. Displacement is a vector quantity. So we take only the down, that is 15. 15 by what's the time taken? Time taken is 3 seconds. So 15 by 3, that is 5 meter per second. Hope you enjoyed the class. Watch my next video of motion. Please like, share and subscribe, and press bell button so that you will get the notification whenever we upload new video. Thank you.